In this class we'll be learning an algorithm called Kmeans, which is an unsupervised learning algorithm. Unsupervised algorithm. So basically in machine learning algorithms you have two types. You guys might know that already, supervised and unsupervised. So K-means maybe for beginners this would be much easier to learn because you don't have to deal with training models which already have an x and a given y value to it. So these are only supervised training models, so we don't have to deal with data sets that already has a given output value. So these are unsupervised. I mean, as the name itself kind of says, there is no given output value to the training data that we have already. There's no given output value. So it's just data that we plot on a graph, and we visually can cluster the data ourselves, but using K-means we can make the computer to cluster things, and the K-means algorithm not only clusters things that are just visually seen, it can cluster things which cannot be seen to the human eye as well. So this is what K-means is all about. This is an unsupervised algorithm which does not have there are all x's. Let's consider x's as the data that we have, but as it's unsupervised, it doesn't have a given y saying, okay, for x this is the y, so that is why we call this unsupervised. So let's go ahead with it. Let me plot a simple graph with just maybe like 5 or 6 data points. Let's say 1, 2, 3, 4 and 5. The y-axis 1, 2, 3, 4 and 5. I'm not yet going to define the x and the y-axis. I'm not yet going to define what each unit stands for here because I'm just taking a normal example. Let's try to define it as we progress through the class. Okay, so let me take 6 or 7 data points. So let's say 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points as our example. Okay, we have 11 data points here. So to the human eye, we can see that this and this are clusters. So now what K-means does is, like, obviously we cannot be there looking at clusters all the time. Why we are trying to learn what K-means means is we want to learn how the computer can segregate clusters. As we are getting into this algorithm, we'll just see how to cluster things which we can cluster with our naked eye. So later we can move on to see how complex clusters K-means can actually segregate really well. It's a very powerful algorithm, by the way. So okay, let me just take the circles out. Let me say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have totally 12, as of now I totally have 12 sets of data points. Okay, so one K-means algorithm basically has two main steps for that matter. First step is the cluster assignment step. Second step is the move centroid step. These steps are when things start to get real. Okay, so first we will consider centroids as mu using the symbol mu. So let's assume we have total k number of centroids, capital K. So we have mu1, centroid 2, ... till centroid k. So the first step, even before the cluster assignment step, is initializing cluster centroids based on the input the user gives. So before, when we are trying to execute the K-means algorithm, we have to say the number of clusters the K-means algorithm should divide itself into. So as this is a beginner example, we'll consider it as 2. We'll say the number of clusters that we want from K-means is 2. So we'll have mu1 and mu2. Total of just 2 cluster centroids. So each cluster centroid has its own cluster around it. So we'll define just 2 cluster centroids for this example. So n is equal to 2. N is equal to 2. Okay, so the first part goes this way. We randomly initialize cluster centroids throughout the graph to any place. So the first step, if you guys can see here, is randomly initialize cluster centroids. So we randomly initialize the cluster centroids. So let us take this as an example here. Let us say, okay, I'll take another colored marker for this one. I'll take red and green. So let's consider the red one as the first cluster and the green one as the second one. So these are 2 cluster centroids that I have defined already. So now let's talk about the cluster assignment step. What the cluster assignment step, this is the main part of the algorithm that we now run into. Cluster assignment step, what this exactly does is, this now considers mu1, which is the first cluster centroid. It compares mu1 and mu2 to all the data points that are available on the graph, and to which each data point is the closest to. So this will be assigned to this cluster centroid. So let us take for an example the distance between this data point and mu1, the first cluster centroid, and the distance between this data point and mu2 cluster centroid. So the distance which is the least to, it compares each data points to, example, this or this or this, to each cluster centroid, and the least distance that it has, maybe we will say the distance here is 2, but this would be 4. So as 2 is less among 4 compared to these 2 numbers, this data point is going to get assigned with the mu1 cluster centroid. So this inner loop is done to all the data points that are available. So let me just erase this real quick. So what now happened is, this data point is assigned to cluster centroid mu1. This is assigned to cluster centroid mu1. So let us generalize. Let's not be too accurate at the moment. So mu1, so this is also closer to this than to mu2. So this will also be belonging to centroid mu1. This will also be belonging to mu1 because this is closer to centroid mu1 than to centroid mu2. And then this one as well and this one as well. So this is the first step that we are done with, the cluster assignment step. As soon as we are done with the cluster assignment step, we move to the move centroid step. Move centroid step. Okay, so let me just, there's some math that I have to write down, so I just erase this part real quick. So we're done with the cluster assignment step, and yeah, we obviously have to mark this as well. So this and this. So the data points that I have marked with the color in which I've denoted the second cluster centroid belongs to the second cluster centroid's cluster, and the red ones belong to the mu1's cluster centroid's cluster. Okay, so I'm just going to erase this real quick. So now we are talking about the move centroid step. So what the move centroid step does is, it takes the mean of all data points that are assigned to one respective cluster, and it takes, as soon as it takes the mean of all of that, mu1 moves to the mean of the positions of all data points assigned to the cluster. Forgive my handwriting, please. That's why I'm making it sure that I'm reading things as I'm reading things out loud as in then I'm writing them. So now let's just consider a vague example. Let's say, okay, these are its x-axis values, and it has its own corresponding y-axis values as well. So mean of the positions, let me say the x-axis distance of this is, towards the x-axis is 1. These are the x-axis distances. Forgive me, these are the x-axis distances. So the x-axis distance with this one is 1, with this it's 2, with this it's also maybe 2.5, with this it is 4, and with this it's 4.5, let's say, plus 4.5. We take the mean of all these numbers. So how many do we have? 1, 2, 3, 4, 5. So we have 1 plus 2, 3, 5.5, 9.5, and we have 13.5 divided by 5. So our value would be somewhere around 2.7. 2.7 would be our value. So this cluster centroid, which is assigned at this random place, as I said, the first step is random initialization of the cluster centroid. So the one that is assigned here randomly is going to move on this axis. I'm not considering the y-axis yet. On this axis, it's going to move to the place close to 2.7 somewhere. So here it's almost at 3.5 somewhat. This is going to, so as I was saying, we'll consider the y-axis values. So 1.5, 1.5, this is almost 3. And then this is almost 4.5, and this is close to 4. So here we have 1, 2, 3, 4, same. 5 data points assigned to cluster centroid mu1. So let's add these up. 3 plus 3, 6, 10.5, 14.5. 14.5 divided by 5 will get me somewhere close to 2.9. So on the y-axis, this is going to be close to 2.9. So this is the x-axis value, y-axis value, maybe we'll consider this point. So what happens now, the cluster centroid will move from this place to this place. So let's not consider this one anymore. The cluster centroid will move from this place to this place. So let's erase this for better mode of reference. And then, as I said, the second point is done. The second point is done, and the cluster centroid, move centroid was the second step, right? So the second step of moving the cluster centroid from the random position to this place is done already. So I mean, it's obviously the same thing. So I'm not going to do it for the second cluster centroid already. So let's say this moves somewhere close to this place. So I'll erase this for better reference. So let's say mu2 is assigned to this. This is the position of the mu2, the second cluster centroid. So now, if you can recall, the same thing happens. What is the first thing? It says the minimum distance between each cluster centroid and each data points is calculated, and it's assigned to the cluster centroid to which it has the minimum distance than the other. So all these are now closer to cluster centroid mu1 than mu2. All 5 that are here, and then all 5 that are here, all 5 that are here are closer to centroid mu2 than to centroid mu1. So as iteratively, I mean, now we were lucky enough to have a graph where we could arrive on the solution just in 2 steps. But Kmeans is powerful enough, you know that many algorithms I've worked on where it takes close to 8 to 9 iterations to come settle on a cluster. So now if we can ignore the red and red and green colors. Now this is assigned to mu1, this whole centroid is assigned to mu2. As this is like an iterative algorithm, so once it's done, if the graph was not like this, maybe it would have went through another iteration where it would have seen cluster assignment and the most centroid step through as well. So at this stage, it'll be the same. Even though the loop is running throughout, no values are going to change because this cluster is not going to move. So maybe we can say inside the loop we can say if mu1 is not changing, the loop can break out of it. So if we can say if mu1, I mean this is just in English, not in any programming language. So defining an algorithm in basic English, I can say if mu1 is not going to change, from that point we can break out of the loop. So if we break out of the loop, the algorithm stops and we have been successful in clustering data points this way and this way. So this is basically the whole Kmeans algorithm, and just to put some math into it, is this part real quick, and the cluster assignment step. The cluster assignment step. So as I said, each cluster, so we'll consider all data points as x and each cluster as c of I, depending on the number of clusters that are available. So let us say now the actual math for the first step of K, means the cluster assignment step, says c of I is minimized with respect to k of the distance between each point to its respective centroids. So this formula actually works. This is perfectly fine, but in machine learning, when we write minimization functions, it's just common practice to square them. So this is the main math that is behind the cluster assignment step. So C of I says, so C of 1 would be this one, the first cluster. So it says things that has to be assigned to the first cluster is the distance between xi and mu k. So mu k, let's say mu1, and xi, let's say, is this point. So the distance between this and this, which gives you the minimum value, as I'm minimizing the function with respect to k. With respect to k means with respect to each centroid, which returns the least value when it's squared between this is to which the data points are being assigned to that cluster. So this is the main math that goes behind, and the math behind the move centroid step is pretty simple, just high school math. It's just saying mu k is maybe x of 1 plus x of 2 plus x of 3, whichever ones that are assigned to this cluster by the number of data points that are there, so 3. So these two formulas are the math behind the Kmeans algorithm. Yeah, that's it. I hope you guys learned something new with this video. Thank you.